a lot of questions we ask are about cause and effects, right? So if I eat 2 liters of ice cream, I don't feel good. Okay, so that's a cause and effect relationship. We're also interested in sometimes counterfactuals, right? So if something changes, let's say I imagine that yesterday I didn't eat 2 liters of ice cream, maybe I would have felt better today. Okay, so that's kind of a counterfactual. And we also are often interested in the effects of what we call an intervention. So if we intervene, let's say we give a vaccine to the population, what's going to happen to the spread of a disease, for example? So to answer these kinds of questions, especially related to interventions, right, we know that we can do randomized controlled trials. And we won't go into the details of why, but essentially the idea, the most simple kind of control trial we could do is a fully factorial experiment. So we have treatments, let's say we have 2 we want to compare, and we just give them to 2 different groups, and we compare the groups. Okay, so this experiment is like maybe the simplest idea we can have. We give all the treatments we're interested in to different groups, and we look at the groups. So this comes from ideas related to agriculture. So I worked on a trial like this, where we take a field of land, we divide it into, 10 plots, and in each plot we give treatments, and we look at the end of the season, how much corn came in each plot, and we look, okay, more corn was there than over here, so probably this treatment is better. And that's kind of like the basic idea of how we design an experiment. And then we can go into more complex designs because we have certain things we're more interested in, or we have limited resources, or we have different constraints that force us to be more creative in the experiment. But these are really like a tool that we use for causal inference, and it was long thought that it was the only tool we could use for causal inference. But today we know that it's not true.